Hello, everyone. Welcome back to the Great Doctrinal Reset. I'm your host, Albert Watson. Today, we will be continuing our discussion on understanding God through simulation theory. Today, we'll discuss time dilation. Time dilation refers to the variation in elapsed time measured by two clocks due to their relative velocity or gravitational field therein. Relative motion. The faster an object moves, the slower time progresses for it compared to an object at rest. A clock in your bedroom will tick faster than one on the International Space Station, which orbits at nearly 18,000 miles per hour. Gravitational influence on time. As you approach massive objects like black holes, time dilates significantly. As you get closer to a black hole, time for you would slow down compared to the rest of the galaxy. How simulation theory answers these questions. Motion. The faster you move within a simulation, the more processing power is required to handle your interactions, much like how moving quickly in a game demands more from the system, potentially causing lag or slowdown. If you use the no-clipping command in Skyrim to fly through walls, you will move at an incredible speed. On your screen, the game will sputter to give it time to catch up and render the world. Massive objects. Just as a supermassive object in a game, like this tornado conveyor belt in the game Satisfactory, causes the game to lag when rendered on screen. Proximity to massive objects, like a black hole, can be understood as requiring more computational resources to maintain the simulation. The closer you get, the more lag or time dilation occurs to manage the system's load. Resource management in our universe. In our simulated universe, time dilation is a mechanism to manage computational resources. As you approach areas with high gravitational fields or move at high speeds, the system slows down time for you to prevent overloading the simulation's capacity to render and calculate physics in real time. In conclusion, time dilation is not just a quirk of relativity, but a necessary function to manage the computational load of our universe. By slowing down time in high-demand scenarios, the simulation ensures that it can maintain stability without overtaxing its resources, much like a game engine would handle performance under strain. Now we'll move to the quantum eraser experiment. The quantum eraser experiment, which is an extension of the double slit experiment, explores the bizarre relationship between observation and quantum behavior. Photon splitting and entanglement. A high-frequency photon is split into two lower-frequency entangled photons. One photon is sent immediately into an unobserved detector, where it should always behave as a wave. The other is bounced off partially silvered mirrors, leading it to either an observed or unobserved detector. Delayed choice. Here is where it gets counterintuitive. The photon hitting the unobserved detector first should always exhibit wave-like behavior no matter what. However, what happens to the second photon, whether observed or not, retroactively influences the first photon's behavior. If the second photon is observed, both photons will act like particles, even though the first should have already shown wave-like properties, as it hits the detector first. This suggests that information or causality travels backwards in time within the quantum realm, meaning what happens second determines what happens first. Gaming analogy, Team Fortress Classic. Latency and synchronization. In the late 90s, with dial-up internet, playing TFC involved connecting to a game server where players could experience significant lag. Lag in action. A player's actions on their screen could be seconds behind the actual server state, with snipers particularly affected. Aiming required predicting the future positions of targets and aiming ahead of them due to this lag. Server-side determination. Valve, the creators of Team Fortress Classic, wanted everyone to play on a level playing field despite their internet connection speed. They introduced a system where your sniper shot on your screen would be transmitted to the server, and if successful from your perspective, the player would be killed on the server regardless of their position in the other player's view. This meant that an action taken in the present, shooting, could alter the past, the player's location, much like the quantum eraser, where the latter event dictates an earlier one. Parallel with quantum mechanics. Retrocausality. In TFC, if you shoot a player who on your screen is in the courtyard, but on the server he has already entered a building, the server would correct this by teleporting a player back to the courtyard and be killed where you shot him. This is akin to the quantum eraser, where observing the second photon changes the past behavior of the first. Observing from the outside. We are aware of this retrocausality in TFC because we are external observers to the game universe. In our universe, we cannot see the initial wave-like behavior of the first photon because the act of observation in the quantum eraser experiment erases that evidence, aligning it with the second event's outcome, just like in TFC. Valve later reinforced the erasure of evidence by reducing the death timers of the person killed to correspond with when they would have actually died had they been killed in normal time. If the player killed made it 8 seconds into the building before being lag sniped back into the courtyard, 8 seconds would be knocked off his 15-second death timer, thereby further erasing evidence that the player ever made it into the building. In conclusion, just as the TFC server adjusts gameplays based on when and how actions are processed, in the quantum eraser experiment, the act of observation forces the universe to conform to the observed state, creating a new past that matches the present observations. This illustrates how both a simulated game environment and our own universe, the sequence of events can be less linear than we might expect, with outcomes influencing what we perceive as their causes. Computer-coded universe. We have discovered what appears to be computer code embedded within the very fabric of our universe's laws. This is not just any code, but a specific type of code known as error-correcting code, pioneered by a mathematician, Claude Shannon, in 1948. This code is essential for maintaining and correcting digital communications when errors occur, much like how it allows CDs and DVDs to still function even when they are scratched. Error correcting code in supersymmetry. Discovered by physicist James Gates in exploring equations related to supersymmetry, Gates and his colleagues found error correcting codes in the paper titled Relating Doubly Even Error-Correcting Codes, Graphs, and Irreducible Representations of N-Extended Supersymmetry. That's a mouthful. And it discusses this intriguing intersection. What is supersymmetry? In simple terms, imagine a toy box where every toy car has a corresponding toy doll, but with different abilities. Supersymmetry suggests that for every particle in our universe, there exists a supersymmetric partner particle that shares some properties but also has unique characteristics. This concept touches on quantum field theory, cosmology, high energy physics, mathematical physics, quantum gravity, and condensed matter physics, suggesting a kind of universal balance where every particle has a twin maintaining cosmic harmony. The implications for simulation theory. The presence of error-correcting code in our physical laws is evidence that we inhabit a simulated universe. Just as error-correcting codes allow for integrity of digital data, they serve a similar function in maintaining consistency of our universe's physical laws. Quantifiability and simulation. As we continue to study our universe, we find that everything can be measured and quantified. This quantifiability implies that if all aspects of our universe can be measured, then they can theoretically be replicated. If they can be replicated, then they can be simulated, lending further credence to the idea that our reality is a simulation. In conclusion, the discovery of error-correcting code within the equations that govern our universe's behavior is evidence that our reality operates on principles akin to those of digital simulations. This pushes the boundaries of our understanding, suggesting that the universe could indeed be a highly sophisticated error-correcting simulation where every element has its place and purpose, much like characters and objects in a well-designed video game. Time travel in a simulated universe. Simulation theory offers a simple, straightforward explanation for time travel, which physicists often seek through complex means. The concept of time travel under this theory becomes simple in principle but challenging in practice within our universe. The precedent of time travel. We have already invented a form of time travel with the advent of the save game feature in video games. The first time machine was Zork, the Great Underground Empire, released in 1980, which introduced this concept. Mechanics of time travel in simulations. Save states. In games like Zork, players can save their current position in the game world, capturing the state of every particle, object, and character at that moment. Reloading. At any point, players can travel back in time by loading this save state, resetting the entire game universe to that exact moment. Time travel defined. Thus, time travel is the ability to reset every particle in a universe to a previous state concerning position, composition, and velocity. And this has implications for our universe. Execution within our universe. While we might not be able to achieve this capability in our physical reality due to the scale and complexity of our universe, the principle is clear in simulated environments. Divine capabilities. If our universe is indeed a simulation, time travel would be a trivial matter for its creator, akin to loading a save game state. This would explain accounts of time manipulation as the actions of a creator with control over the simulation's parameters. In conclusion, time travel as a conceptualized in simulation theory is not about finding a physical or temporal loophole, but rather about manipulating the state of a simulation. Just as in video games where we can save and revert to previous states, the creator of a simulated universe would have the power to rewind or alter time at will. This perspective demystifies time travel, suggesting it is not an arcane physical phenomenon, but potentially a feature of the computational architecture of our reality. How God sustains our universe. In a universe as vast and detailed and complex as ours, sustaining it would require an unimaginable amount of processing power, much like how computer processors render and maintain a digital world. Scale of processing. Current computer processors manage to render images for just one screen, but our universe renders reality for over 8 billion individuals. The computational demand for Earth alone is colossal, and if humanity were to expand across the cosmos, the required processing power would be beyond our comprehension. The sustainable simulation model. Simulation within simulation. If we are living in a simulation, then even the processors in our computers are simulated within this larger simulation. This leads to an intriguing hypothesis. Self-sustaining processors. The most sustainable method for maintaining this universe is if the universe itself generates its own processors. The theory is that we, as living entities, are also the processors that help create and sustain the universe. This would ensure that there is always enough processing power to keep the simulation stable. Stability through self-regulation. If the universe dynamically adjusts its processing power based on its inhabitants, this would explain why universal constant remain constant. This includes with laws with time dilation and other physical laws. The idea that the universe's processing power is always sufficient means phenomena like time dilation would occur at a constant rate, furthering the illusion that these are natural physical laws rather than computational limitations or lag within a simulation. In conclusion, this model of sustainability where we, the inhabitants, are part of the processing system offers a vision of an infinitely sustainable universe. It suggests that the creator of this simulation does not need to supply external processing power. Instead, the universe could be designed to self-regulate and self-sustain, ensuring that the simulation can continue indefinitely while maintaining the integrity of its physical laws. This concept not only aligns with the idea of divine efficiency, but also within the principles of simulation theory, where the very participants in the simulation could contribute to its computational needs. Simulation theory, revelation, and manipulation. Good theories not only answer questions, but also bring new understanding. Simulation theory does this by providing insight into how great miracles of the Bible are possible. In John 20:19, Jesus walks through walls, which can be analogized to the no clipping command in video games, allowing passage through objects. In 2 Kings 19:35-37, God annihilates an entire army overnight, much like the kill all command in Skyrim would do to NPCs. Jesus raising Lazarus from the dead parallels the resurrect command in Skyrim, where a dead NPC can be brought back to life. Daniel 5:20-22, King Nebuchadnezzar was changed into a beast-like being. This is done in Skyrim with the set player race command. Mark 4:35-41, Jesus calms the storm. The same way it can be done in Skyrim with force weather command. This is why Jesus said, all things are possible to he who believes. If we live in a simulation, everything is a single command away. Importance of laws in a simulated universe. The value of laws. Laws give everything in a simulation value. If these laws can be freely broken, existence becomes meaningless. Miracles in the Bible, which often require faith or a high price, reflect this principle. If miracles were commonplace, then they would lose their significance, much like cheating in a video game diminishes the value of the game itself. Consider the difference between a rock found on the ground and one found from the top of Mount Everest. The effort to obtain it creates meaning and value. Rules in culture and nature. The 1990 game Genie allowed players to bypass game rules in Nintendo games. Initially fun, but this ultimately led to disinterest because player actions had no value when rules were broken. Whether in sports, games, stories, or our universe, rules provide structure and challenge and meaning and value. The backlash against The Last Jedi illustrates how breaking established rules can devalue a narrative-created universe, as fans felt the actions lacked weight or consequences. Conclusion on rules. Just as it has previously been stated, God is not the ultimate creative force. Rules are the supreme creative force for all existence. Rules are everything, and nothing can be created without rules. Understanding the supremacy of rules gives us the needed insight into understanding God and his behavior. The biblical and natural laws that God has created should be the guiding principles in all theological thought and conclusions. The meaning of life. Purpose through creation. The meaning of life is to create meaning for life. In churches, I have observed a pattern of God giving frequent messages and prophetic words to individuals with the words, I have a purpose for you. This aligns with providing challenges and problems to solve, akin to Jim Preston's motivation in the film Passengers for seeking purpose through problem solving in a new world. Jim Preston states, the colonies, they have problems to solve. They're my kind of problems. And a mechanic is somebody. It's a new world, still being built. Ongoing creation. Psalms 82, verse 6. You are God's, and all of you are sons of the Most High. This foretells that humans are destined to create in God's image, perpetuating a cycle of universe creation where each new universe must have meaning and purpose for its inhabitants. This becomes in every universe a supreme law that must be maintained above all else. In conclusion, combining the necessity of law with the idea of a simulated universe, we find that our purpose is to engage with the world, solve its problems, and thereby create value and meaning. This cycle of creation and purpose is not just a feature of our universe, but the hallmark of all simulated existences, suggesting an endless chain of creators and creations, each bound by and deriving meaning from their rules. Well, that is it for today, everyone. Next time, we will be covering the social psychology of God. Until next time, I'll see you then.